Hello everyone, welcome to Lab 5. I'm Ruzbe. Today we have two exciting experiments, and the first one is with that one little guy. He will go closer and show you the details. And the other one is this big guy to show the flow. So about the detail, about the first one is the turbine. The basic theory for this machine is like the flow coming and the force push the turbine and increase energy. So we will check how we can add the friction to cancel the energy. So here, as a detail of this machine, we have the flow meter here. We will see the flow coming inside the machine. We have a pressure gauge here. It shows the pressure when it comes inside. And we have some weights here. By adding these weights and adding the friction, we can control the RPM of the machine.
Sam is getting it going.
Cooling that's this guy, right?
Yeah, I pulled off this.
Yep. A lot of bodies down there.
We can understand the flow rate coming from the pipe down. So the water is coming from the top to down, and this gauge can measure the flow. And here we can see the pressure of water coming inside the turbine and added the force to the turbine and make it turning. So here we see the shaft which is turning, and here we can add the tension to reduce the RPM of the turbine, as you see. But at the beginning, we release all the tension, so it's turning with the maximum speed. And here, we upload the weights. And try to set that to 0. As you can see, here it is not 0. So we have to calibrate with this. Now it's calibrated to 0.
So the velocity for starting is 7.39 feet per second. That is the velocity of the water.
And we got the pressure gauge showing 53 psi, which is the pressure coming inside and is responsible for turning that wheel. So in the first step, we add 400 pounds. Tension. To the point which equilibrates. You see, I started to the point that comes to 0. And then tracks around per minute. Understanding the RPM of the shaft, we use this tachometer. So by keeping the test and pointing at this white bar like this, you can see it's showing that The RPM is 1195. 1190.
The velocity for trial 2 is 7.24 feet per second.
Okay, in the next step, we add more, 200 pounds more, like this, and do the same thing. Try to increase the tension. Equilibrate. Now you can see it's again on 0. So again we test the RPM. Now we turn to 1151. 1151.
We got a video of one of us driving.
50 psi.
For round 3, we're at 7.22 feet per second.
In the next round, we repeat that again. We add another 200 pounds. Increase the tension. You see the RPM drop. And then again, read the pressure and the flow.
Still 50.
It's still 50. And also track the discharge rate. So by the end of the round 3, we have to track the RPM, which is 1084. And
So round 4, and we were at 7.19, about 7.2 feet per second.
round 4, we add another 200 pounds. Try to increase.
Oh yeah, that's
Now it's again equilibrate. Read the RPM. 1030. 1030, yeah. Again, read the pressure,
Still
which is 50. And again, we will read the lows.
7.16 feet per second is the flow of the water for round 5.
Round 5, we again add another 2 pounds. So far, it's 12 pounds. A bit more. And then again, test the RPM. It will be 9,071. 904. Sorry.
49.
The pressure is still around 50. And again, we'll check the
For round 6, the flow is about 7.15. It's been fluctuating, but we're going to go with 7.15 feet per second.
we also add another 200.
Wait, what?
Again, increase the tension. As you see, the RPM is dropping, and you can hear me better. So
Oh, yeah.
here again, we test the RPM. It is 929.
It is
The
40,
pressure is
49 psi.
49 psi. So in round 7, we already have 14 pounds. So we add another 2 pounds. It will be 16 pounds. Again, we try to increase the tension and lower the RPM.
A little bit down. Yeah, that's good.
Okay, now it's equilibrium. Then again, it tests the RPM. 869, 858. Again, check the pressure.
49.
49. And track the in round 8, we add another 2 pounds. Try to add tension. No,
That's a little too high.
a little too high.
That's good. That's good.
Okay.
Yeah.
And again, test the RPM. 773. 773.
773.
Yeah, 773. And again, the pressure is still 49. So now we are on round 9. So we added 20 pounds. We upload everything and add 120 pounds. Then again, we try to add tension.
Again.
Now it's equilibrium. We always try to check the cooling, add water, but not overflowing. Again, we try to test the RPM. 696. We will check the pressure again. 49. Okay, now it's the final round. We add another 2 pounds to the liver. Add it to the complete equilibrium. You will see that it's almost stopping working.
That's good.
Okay. And the RPM is 620, 615 round per minute. 615. 615. Also, the pressure gauge is still showing 14.9. Final step, you might need to calculate the force based on 2 formulas. The first formula is from momentum analysis. So as you can see, this is the force per unit of width. It means it's the force per 1 unit of, 1 inch of width all over the channel. So you have to just multiply that with the width of the channel that you calculate at the beginning of the experiment. So for both of the velocities, you can easily calculate based on y1 and y2, and you can find the velocity of upstream and downstream. Then from the other formula, you can also find the force based on the integral of the pressure all over the surface of that channel. So that's all. Good luck with the calculation and the lab number 5. Okay, in the second part of our experiment, we are using the tilting flow for measuring for doing the sluice gauge experiment. So in this experiment, we have upstream flow and a gauge, and water is coming from downside of the gauge and becomes stable on the other side in the downstream and goes toward the end. We want to understand the force behind this wall, and based on the calculation, there are 2 ways to calculate this force. You can easily find out based on the formula. So all we need to calculate in this experiment is understanding the height. First, we have to turn on the pump 1, stabilize the water, so the water level should stay constant.
Oh,
So
it was
we will-
constant, wasn't it?
No, it went up. We set that on 15. So we try to set that on 15.
15 inches?
15
Upstream
inches.
depth?
Yeah, exactly. So it's now constant. So we have downstream flow. We have to measure the downstream flow height, which is half an inch, 0.5. The area beneath the gauge, which is 0.25, and also the gauge width, which is 12 inches.
12 inches.
So the last thing that we need to know is the flow. So the deflection here. So the last thing that we have to read is the pump discharge, which is going to be shown based on the deflection. The deflection is 0.17 minus 0.99, 1.99. I'm sorry, 2.17 minus 1.99. It's a deflection, so we have to go to find this deflection here, and since it is the large orifice, we have to find the deflection, come to the large orifice line, and then come down, then we can find the discharge rate. In the last part of our first trial, we're gonna read these manometers. So, are you ready for the manometer?
This is
So, I will read the manometers from down to top. So the first one is 1.03. The second one 1.11. The third one 1.14. 1.18. 1.19, 1.2, again 1.2, 1.2, 1.2, again 1.2, 1.21, 1.21, 1.21, and yeah, 1.21 to the right. For the second trial, we try to open the gauge. Open the for one turn.
One turn for the second trial.
Yeah, for the second trial. So we again gently measure the YS, which is now 0.5 inches. The
15.25 inches upstream.
Yeah. And for downstream, 0.6.
0.6 for the downstream height.
And for calculating the discharge rate, the deflection is 0.24. Oh, excuse me, 2.24 minus 1.85. Go for reading the barometer. So
We can go back to what we were doing.
from down. Are you ready? Okay. Right. So the first one is 1.01,
1.01.
1.07, 1.12, 1.16, 1.18, 1.19, 1.19, 1.19, 1.19, 1.2, and 1.2 to the right. For trial speed, we again try to open that for one more turn. Again, calculating the YS, which is 0.75.
Okay.
Two different deflections, two sets of deflections. And the cues on the average meter.
Okay.
So the upstream level, we set that to 15.25. So the area beneath it is 0.75.
0.75 inches.
And here the downstream is 0.8 inches.
0.8 inches. Very nice.
So we'll go to the barometer.
Yep.
So the first one is 0.96. 0.96 was the first one. The second one is 1.04, 1.1, 1.15, 1.17, 1.18, 1.18, 1.18, 1.19, 1.19, 1.2 to the right. And also the deflection for the manometer is 2.32 minus 1.49.
Small orifice.
No, the large.
Oh, never mind. Pump one.
Pump one, large orifice.
Pump one,
Pump
large
one, large
orifice. Thank you, Sam.
Okay, and trial number 4. Open that another round. So the area is, let me just fix it to 1. Okay, it's 1 inches.
1 inch.
1 inch wide.
We're running out of water.
Okay, in the fourth trial, we try to open that another round. So the YS will be 0.8
Inches.
inches. Yeah. Also, we set the upstream flow on 13.4 inches. Yeah. And the downstream flow 0.9 inches. And the manometer. The first one is 0.77, 0.87, 0.93, 0.99, 1.02, 1.03, 1.03, 1.04, 1.05, 1.05, 1.06, 1.06. The rest, but the last one is 0. It's above the water level.
Trial 4, deflection.
I don't know if the deflection is going to be
No,
about.
we cannot track any deflection.
No deflection.
You say like, since we're using more of the orifices, this is no longer a valid measurement, so we're not going to get deflection and the pipe manometer flow for this one.
So in the final round, we also tried another term. So the YS will be 0.9 inches.
0.9 inches for the height of the gate.
Okay, so the upstream is 10.2. And we saw that YS was 0.9 inches. And for the downstream flow, it is 0.8.
0.8 inches.
Sorry. The first one is 0.55. The second one is 0.63, 0.66, 0.7, 0.74, 0.75, 0.76, 0.76, 0.76, and 0.77 to the end, except last two. Last three are 0 because they are out of the stream flow.
I'll just read them off to you. 0.19.
So the 0.19, 0.19, and which orifice did we use?
We cut this off and need this anyway.
Did we use
You can cut
large
it off.
orifice?
I think we're good.
So
What?
did we use large
Oh,
orifice?
pump one.
So we use large orifice, I guess. That was a large orifice or
Kind of one large one.
4.1 large orifice. So we'll go to large orifice. So it will be around 0.9
CFS.
CFS, yeah. What about the second
For
one?
trial.
Trial 1.
Trial 1. Okay. Now trial 2.
0.39.
0.39, 0.39, and going to large orifice.
then go down, it will be around 0.15.
0.15.
For trial 2.
For trial 3.
Now
So trial 3,
Oh, sorry.
Now trial 3. Yeah.
Now trial 3 is 0.83.
0.83, and then go to large surface. It will be 0.18, around 0.18.
Okay,
Okay, that's all.
cool.
Get a close up on that for you guys. This is Castine's guinea pig.